What is up, guys? This is Luke Hill for Kit Guru, and AMD's X570 platform has been around for a while, but it's kind of gone off the boil a little bit, and that's especially true with B550 stealing some of the thunder in summer 2020 because of its fully passive design and its upgraded feature set versus the July 2019 launch for X570. That passive point is really critical though, because that was one of the strong preferences for B550 versus X570. Now, we did see a couple of passive X570 boards, one from ASUS, one from Gigabyte, but they typically had a chipset fan, and this was a bit of a moot point with many enthusiasts who didn't really like it, myself included, having used the X570 platform on pretty much a daily basis for over 2 years now. But this is where X570S, if you prefer, comes in. So some of those new 2021 features are brought onto the new motherboards from the vendors, and we have a fully passive chipset heatsink, which means a fully passive motherboard. Now, before you get your hopes up for a new actual chipset, no, this is the same old X570. We spoke to AMD and they actually confirmed this is the same chipset, so no change to the process node or anything like that. So the X570S moniker is basically just marketing material by the motherboard vendors. I guess S is for silence. Smart one there, right? But anyway, this is the same X570 that we all know and love. Fantastic platform, great chipset with PCIe Gen 4 throughout. And if we can get that big downside, the chipset fan, off the motherboards, fantastic. So in doing so, we're going to be taking a look at two passively cooled X570 offerings. The first one is the ASUS ProArt X570 Creator Wi-Fi, and this is about 360 or so pounds in the UK, clearly targeting prosumers with a workstation type system. And then we've also got the roughly £340 Gigabyte X570S Aorus Master, and this is clearly targeting high-end enthusiast users, so gamers and general enthusiasts. Interested to see this one because we loved the X570 Aorus Master back in its original days, so we want to see what's updated here. But anyway, let's take a closer look. Before we do that though, if you like what we do here at Kit Guru, make sure you like and subscribe to the channel. You can support the channel via YouTube, you can help us out on Patreon, you can buy a cool t-shirt like this one, and make sure you head on over to the Kit Guru website where you can get all the detailed information. Let's have a look at the ASUS ProArt X570 Creator Wi-Fi. So starting out with a general look at the motherboard itself, we can see that it's a pretty generic appearance. We've got the normal design, dark blacks, dark greys. We've got a bit of plastic on the chipset heatsink, and you can see in general the heatsinks are pretty oversized. Looking at the connectors, we've got 8-pin plus 4-pin for the power. We've got fan headers along the top edge of the motherboard. You actually get 8 fan headers in total. Disappointingly, I guess, these run at 1 amp in general, except the water pump header, which is 3 amp rated. So if you power in a bunch of fans off splitters or some high power fans or pumps, then you do have to watch out for that. In the 24-pin area, there's nothing of real note. We don't see any voltage monitoring points or any onboard debug LED, the latter of which would have actually been quite useful, to be perfectly honest. We do, however, see a 10 gigabits per second USB 3.2 Gen 2 Type-C header, and this is fantastic for front panel Type-C connectivity. Moving down to the SATA area, the board's only 5 gigabits per second USB 3 header is found here. This is right angled, so watch out for interference in your case. And you get 6 SATA 6 gigabits per second ports, all run from the X570 chipset. In terms of expansion slots, the 2 strengthened full-length slots run with Gen 4 lanes from the CPU, so these can either run at X16, X0 or X8, X8. You do have to watch out for the second slot, however, because it shares its bandwidth with one of the M.2 slots. So if you install a by4 SSD in M.2 slot 2, then that will steal 4 lanes, so then you're limited to X8, X4, plus an X4 SSD. That probably seemed like a good idea in ASUS's wisdom to give you extra capability for an M.2 device through the CPU, as well as the CPU dedicated M.2 device that we always see. However, in reality, this does really limit your ability to use dual by8 graphics cards, which actually might be useful for rendering or animation on a motherboard such as this. So a bit of an oversight there. ASUS probably thinks you're going to be gunning for a RAID card or a NIC or something like that, but I do think dual GPUs with a bunch of M.2s is quite a reasonable use case for this type of motherboard, so I'm not overly impressed by that allocation choice. And then the bottom full-length slot is PCIe Gen 4 by 4, running with the lanes from the X570 chipset, and thankfully this doesn't share bandwidth, so you don't have to worry about any headaches here. There's no buy one slots, but realistically that's probably not a big deal given the onboard components that your glorious motherboard gives you. We've got triple M.2 slots in total, and the top two run from PCIe lanes from the CPU directly. So this is unconventional. Typically we get one of the slots from the CPU and then the rest from the chipset, but this is good for a prosumer or a workstation type motherboard like this because it alleviates any bandwidth headaches when routing from the CPU to the chipset. Instead they both go direct to the CPU. That's pretty good to see, but obviously comes with the caveat that we've already mentioned for the PCIe slot. The final M.2 slot then is run through the X570 chipset and still supports Gen 4 SSDs. For cooling, you get two strip metal heat sinks, one of which obviously covers two of the SSDs. So this is both good and bad. It's good because if you have one SSD installed, you actually get double the cooling area roughly, so you can overpower that cooling. But it's bad because if you have two SSDs installed with dissimilar cooling configurations, it's not ideal in that use case. So if, for example, you've got a Corsair NVMe SSD with a big fat heatsink on there that you actually want to use, and then you've got a bare OEM SSD, for example, you can't really cool that bare SSD unless you remove the heatsink from the Corsair, for example, SSD. So not ideal there. I prefer individual strips, but I can see the benefits too. And in terms of actual cooling, I don't really see any headaches here, to be honest, because they do have thermal pads on the metal strips. If you've got dual-sided SSDs, you're probably going to have to watch out there, as there's no underside cooling. However, when it comes to installation, this is superb thanks to ASUS's toolless quick latch mechanism, which really is very innovative. That's a good design, I like that. The rear I/O is absolutely phenomenal, and this is where ASUS really shows off the prosumer credentials of this motherboard. We've got dual Thunderbolt 4 Type-C ports, so these are 40 gigabits per second rated for overall bandwidth. So with that DisplayPort connectivity, that means you can actually output to a 4K display, such as the ProArt PA279CV, which is 4K HDR Type-C capability. I've been using that for a bit over the past few weeks. Really good display. I do like it very much, and I can see how these two products could blend up quite nicely with that Type-C connectivity for the monitor. Networking is also outstanding. You've got 10 gigabit Ethernet RJ45 capability through a Marvel AQC113 NIC, and that is really good for Soho use because it's RJ45, so you can do a direct point-to-point connection with a NAS, or you can go through a switch if you prefer. And of course, I say point-to-point because you do get the Intel 2.5 gigabit backup, so you've got dual LANs. So if you want to do point-to-point to your storage server because you don't have an expensive 10 gig switch, you can do that, and then you can use the 2.5 gig for general internet connectivity. That's a smart implementation for networking. And then add in the Intel AX210 Wi-Fi 6E wireless capability, and this is a very well-equipped motherboard for networking. And then of course, rounding out, you get plenty of Type A ports. Type-C, which is Thunderbolt, of course supports USB capability as well, and then you've got the BIOS flashback button, which I really like to see, as well as a 4K 60 HDMI 2.1 if you, for some reason, are using an APU with this motherboard. The VRM is 14 plus 2 power stages, and these are running a team design. The PWM controller is a DigiPlus ASP1405i controller. That runs the power stages in teamed mode, so it's not as granular as a true 16-phase digital solution, but it should be perfectly fine if you're using high current capability power stages. And the power stages that ASUS opts for are onsemi FDM-F3170 smart power stages, and these are rated at 70 amps instantaneous peak current handling capability, so they should be fine for X570 usage, especially with good cooling on top of them. They're not the best power stages on the market, but they're going to be competent. I'm pretty confident of that. The heat sinks are realistically two large slabs of metal that have kind of, I'm going to say, minimal effort to thin them or enhance the surface area much, but they are hefty, weighty blocks of metal, so they should be fine from a thermal capacitance perspective especially, but overall cooling, they're going to be fine, especially with efficient power stages underneath. The two blocks are not actually connected via heat pipe, they are individual, so they have to manage their own cooling themselves, but the distribution of the power stages underneath with 10 on the side and 6 on the top is probably fine given the size distribution of the actual heat sinks. And then underneath the heatsink for the VRM is another strip piece of metal, and that cools the Marvel 10 gigabit Ethernet controller. A large block of metal covers the X570 chipset, and of course this comes without a fan given the passive moniker for this motherboard. The slab of metal is, quite frankly, so oversized that you're not going to have to worry about any cooling concerns for the X570 chipset, and it spans such a large surface area that you're going to get some degree of incidental airflow there. And then just another point to stick in there is that ASUS does actually qualify this board for 24/7 operation, and they do test for 24/7 operation. So that just gives you a bit of peace of mind if you are running this in a workstation type environment where you do run multi-day simulations or animations or renders, for example. Overall then, for our closer look initially, it looks like ASUS has designed a smart motherboard with strong cooling and sensible layout configurations, as well as a really promising rear I/O and connectivity section. The UEFI used is the same that we've come to know and respect from ASUS. Navigation is swift, efficient, straightforward. There are more features included for this prosumer level of motherboard, such as additional security settings that can be controlled within the BIOS, but you still get the important general system and clock speed and voltage management options, though LLC is equally as confusing as usual for ASUS. Please fix this, guys, please. In terms of fan control, it's also the same that we've come to expect from ASUS. Overall, the system's very good with its ability to set multi-point curves, hysteresis, and different temperature sensor inputs. However, the SmartFan 6 solution shown off by Gigabyte does seem to be a little more advanced and user-friendly in some respects. Overall, though, ease of use and general functionality is strong, and the added security and visualization type features are welcomed within the UEFI. Looking at the Gigabyte X570S Aorus Master, we get what I would consider to be a superb aesthetic design from this £340 in the UK motherboard. Dark blacks, dark greys, a smidgen of RGB on the rear I/O, a very solid, stiff, sturdy backplate. This is an exceptional design motherboard, especially with those slabs of metal everywhere, which are actually functional. Looking at the connectors, we've got dual 8-pin for the CPU power. Along the top edge, we actually have four 4-pin fan headers, which is really good to see, and another one over by the CPU power connectors. So in total, this motherboard has 10 4-pin fan headers, and they're all 2 amp rated, which means they can run a water pump or multiple fans via a splitter perfectly fine. Gigabyte deserves a lot of credit for that. That's an excellent implementation, especially because you get 5 RGB headers on board as well. Looking over in this top edge, we get some voltage monitoring points, which are pretty good for enthusiasts and overclockers. We've got onboard power buttons, and you've got the default reset button, but this can be edited if you prefer. We've got more fan headers along the board edge, so great for cable management, and then an internal USB 3.2 Gen 2 10 gigabits per second Type-C port for front panel Type-C. The 2-pin header is for an included temperature sensor cable, and this just gives you additional controllability for your fan speed curves. It's also good to see the 4 onboard debug LEDs in a visible location, because these just give you a notification that everything's going fine during post. All 3 of the expansion slots are full length and steel reinforced. They run at X16, X8 and X4. The bottom X4 slot is driven by chipset lanes, so do watch out for any bandwidth limitations, especially if you're communicating a lot of data between the CPU and X570 chipset. We should also note that it shares bandwidth with one of the M.2 slots, so this is basically an either or here, and that's absolutely fine given that you've got 4 onboard M.2 connectors. And those M.2 connectors, the top one actually runs from the CPU lanes and the other 3 run from the chipset lanes, so do watch out if you're putting a big braid system in there, for example. As far as M.2 cooling goes, the X570S Aorus Master is exceptional. This top heatsink for your CPU fed M.2 is absolutely massive. It's called Thermal Guard 3 and it's tiered, it's stepped above. It's actually got fins on the M.2 heatsink. Easy to install, easy to remove, very, very good there. And then you've got basically a large slab of metal covering the 3 other M.2 devices. And there's so much mass here, you will not have to worry about Gen 4 SSD cooling. The other benefit for the cooling mechanism is that Gigabyte provides a double-sided system. So you do get a thin plate underneath each of the M.2 slots, so you can cool double-sided M.2 SSDs. And then moving around to the rear I/O, we are inundated with USB Type-A ports, including some of the older, slower ports, which personally I still like to see for low-end peripheral usage. You've got 5 10 gigabits per second Type-A ports, and then the Type-C port is actually 20 gigabits per second, and that runs from an ASMedia chipset. Networking is a 2.5 gigabit Ethernet from an Intel NIC, and that's a bit disappointing. I would have liked to see at least 5 gigabit, or maybe even a secondary NIC on here. Definitely a secondary NIC, to be honest, but at least 5 gig on the high-end one. And then Wi-Fi actually makes up for some of the disappointment, in all honesty, because you get Wi-Fi 6E from an Intel AX210 controller. So that is 6 GHz capable if you've got a fancy new router. In terms of onboard buttons, we've got the clear CMOS, which is fantastic. Always like seeing that on an enthusiast board. And then we've got the Q-Flash Plus. One point worth noting is that there are no video outputs on this motherboard, but realistically, who's going to be using something like this with an APU? In terms of power delivery solution, the motherboard is a 6-layer mid-loss PCB according to Gigabyte. The power delivery solution is 14 plus 2 phases, and these are actually phases as well as stages because you get that 16-phase Infineon PWM controller, which is a true 16-phase digital unit. And the name of that controller is dreadful. It's the XDPE132G5C. Yeah, not the best name, but functionally this is pretty much one of the best PWMs on the market, so credit to Gigabyte there. This is a really high-end offering, especially when it's using the Infineon TDA21472 power stages underneath, because these are 70 amp rated power stages and are pretty much some of the best power stages on the market. So overall, this is a massively, massively overkill VRM solution. You probably don't even need a competent heatsink on top of the MOSFETs, but Gigabyte does give you that, thankfully. And when I say Gigabyte gives you a good heatsink, they give you a good heatsink. This is exceptionally well designed for VRM cooling. So starting off with a flattened 8mm heat pipe connecting the 2 fin arrays. That in itself is pretty impressive because that is a fat heat pipe to use for a VRM heatsink. Now Gigabyte highlights a new manufacturing process, but it seems to be cast or perhaps sintered. Not quite sure there, but what I can see is that the fin pitch is very, very good for enhancing surface area while still picking up incidental airflow. So you basically get more surface area in the confined volume. And what you will notice is that this heatsink is actually quite low profile, so you don't have to worry about air cooler interference like you do with some of the other X570S motherboards. While you do get fins on the top, you also get a decent slab of metal underneath, so you do get that thermal capacitance benefit. And Gigabyte does highlight a dark black nanocarbon coating, which may have some thermal preferences for the actual abilities, but more than anything, it just gives it quite a rugged, cool look in my opinion. But let me know in the comment section if you disagree with that. So yeah, exceptional VRM heatsink design. And when we look at the chipset heatsink, that's also perfectly fine. Some thermal paste connects the X570 chipset to a rather large slab of metal. Nothing fancy going on here, but it's a big chunk of metal without a fan, so should be perfectly fine for keeping the X570 chipset in check. If we summarize our closer look at this stage, the X570S Aorus Master is a premium motherboard and is pretty high-end in every respect. Despite having just the single 256 megabit BIOS chip, not the typical dual BIOS redundancy that we often see from Gigabyte, I'm happy to see some of the updates for this UEFI implementation. As always, scrolling is fast and efficient and the easy entry mode is functionally useful. The interface feels a little cleaner and a little easier to use versus previous generations, but the important inclusions such as a graphical display for load line calibration remain included. SmartFan 6 is a full screen in-depth display with excellent mouse control capability, and there's lots of controllability including different curves or even steps or hysteresis control. It's really good manual control as far as mouse functionality goes, and the different temperature sensor sources, including external headers that are bundled with the motherboard, are really good to see. It's also very easy to copy the settings across to different fan headers, and this is a really underrated trait because if you spend time tweaking one header, you'll probably want to use that same curve across a bunch of your headers. And another positive is that the data updates in real time and can be saved in different profiles with ease. I've said it time and time again, SmartFan 5 was excellent, and there's some subtle tweaks that make SmartFan 6 even better. As far as I'm concerned, this is a market-leading solution for fan control through the UEFI. I don't see anybody competing with Gigabyte at this point in time. So just a quick note on one of the new features that Gigabyte has included. That's Active OC Tuner. Now we have seen this previously, most notably on one of the ASUS ROG motherboards for X570. But basically what this tuner does is allows you to use Precision Boost Overdrive as well as a manual overclock for your processor. So PBO has the benefit of high boost frequencies under lightly threaded or low core count operations, whereas manual OC that you've tuned yourself with frequency and voltage in mind will typically give you a higher all-core speed versus PBO. What we see Active OC Tuner do in practice is when we apply a manual overclock such as 4.4 GHz in our testing, and then we run something like Blender, it will stick the chip at 4.4 GHz. But once that all-core load is removed, you then want the benefits of PBO for gaming or for single-threaded workloads where you can boost up over 5 GHz on a Ryzen 9 chip, for example. And that's exactly what Active OC Tuner does. We did notice during our testing with the default mode that if you get between 90 to 95 degrees Celsius on the CPU under the manual conditions, you will typically throttle back down to PBO, and this can cause a bit of a stall in between as your frequency drops, so do watch out for that. But if you tune your overclock competently with a good cooler and keep it below a sensible temperature level, you can then simply flick this switch to add on PBO capabilities and benefits during system usage. This is a really cool feature. Like I say, we've seen this previously on ASUS ROG boards. Really good to see Gigabyte including this new feature. I do like it. Anyway, I think that covers a lot of the core look at both of these X570 motherboards. So let's jump into the testing. Our test system is built around the Ryzen 9 5950X processor. We use 32 gigs of Corsair Vengeance LPX 3600MHz C16 DDR4 memory. We've got an Acertec 280mm all-in-one liquid cooler. A Gigabyte RTX 3080 E-Glow C graphics card powers the frames. Seasonic's 1kW titanium rated power supply delivers clean juice. And we've got a couple of WD Black NVMe SSDs, so a Gen 4 and a Gen 3. We use the latest BIOSes available for both boards at the time of testing. And if you want more details on our test procedures or our test system or our hardware, check out the Kitguru website. Let's jump into it. Stock performance is neck and neck between these two passive X570 motherboards, and that is not surprising given the quantity of on-chip resources. We did see ASUS running very slightly quicker in general for the CPU bias tests, but this flipped in favour of Gigabyte for the more gaming-focused benchmarks. Memory performance was also similar between the two motherboards. Gigabyte delivered a little over 7 GB per second peak speed for our WD Black SN850 NVMe SSD, while the ASUS board's scores were almost identical. Neither board provided any restrictions. Gigabyte did look to have an upper hand on the department of SSD cooling though, and this comes as little surprise given the oversized bulk of its ThermalGuard 3 heatsink, which does an absolutely superb thermal management job. Manual overclocking was as straightforward as we would expect from both ASUS and Gigabyte. For ASUS, the trick is trying to decipher the load line calibration actions and then picking a voltage that makes sense. That got us to 4.6 GHz at 1.3125 volts with level 3 load line calibration. With Gigabyte, the LLC setting is easier to comprehend thanks to the UEFI directions. We settled on 4.6 GHz at 1.312 volts and medium load line calibration. 4.6 GHz is about what our chip likes. Overclocking performance is close between the two boards at the same CPU overclock. A worthwhile performance boost is clearly achieved with the Ryzen 9 5950X run at 4.6 GHz. That's especially true for the Gigabyte board with the Active OC Tuner, where you can keep the benefits of PBO if you like. Power draw favours ASUS slightly at stock, but the favour quickly turns towards Gigabyte as the load is ramped up. While Gigabyte's PBO numbers look good, the ASUS board was run at a higher clock, so it deserves more credit. ASUS looks to be more aggressive with its default Precision Boost Overdrive settings based on our testing. Neither board had any troubles pushing CPU package powers in excess of 220 watts. We could have tuned the OCs better on both boards, but they handled the Ryzen 9 5950X just fine. Gigabyte takes another small temperature victory in the VRM cooling department. With the X570S Aorus Master pull-in 381 watts wall power, it actually manages to keep its VRM running a couple of degrees below the ASUS board at a similar power level. We also see VRM cooling outperformance at stock clock speeds. This is a testament to Gigabyte's superb VRM component and cooling design, but ASUS is clearly no slouch either. Even with extended CPU plus GPU load and dumping energy into the motherboard's metal heat sinks and the PCB, we had absolutely no indications of concern about X570 chipset temperatures. X570 passively cooled is clearly a thing, and based on our testing, there is no cause for concern. That is great news. There we have it then. It's great to see two new high-end passively cooled motherboards breathe in new life onto the X570 chipset that we all know and love. The passive cooling worked very, very well on both motherboards in our testing, and this really is a testament to the competent heatsink design that has been used for the chipset. I guess the only question I have at this point is, what took them so long? Yes, I know there's 2 other X570 motherboards that have been around for a long time with passive cooling, but come on guys, you could have done this quicker. Better late than never, right? And then it's also good to see obvious signs of the 2021 feature set on both of these motherboards, most notably with 2.5 gigabit plus networking and their Wi-Fi 6E connectivity. Looking at the ASUS ProArt X570 Creator Wi-Fi motherboard, ASUS does have a really unique positioning on X570 here by offering prosumer features such as 10 gigabit networking and Thunderbolt 4 to this mainstream, fundamentally mainstream platform. Add in the advanced security capabilities through the motherboard, and we can see this being a really promising option for work from home users or perhaps freelancers or self-employed people who really do need a lot of grunt, but they still want to stick with that mainstream platform and all the benefits that that has. Now yes, there are some downsides. I think the PCIe allocation is not ideal, as we explained in the closer look, and the fan capability, especially if you power in heavy splitters, is also not great. But to see ASUS implement a fantastic Thunderbolt 4 solution on this motherboard alongside some really good networking capability, that is very, very promising. I can see a lot of prosumers being really interested by this board, especially because it's passively cooled and tested for 24/7 operation, which gives you plenty of peace of mind. So overall, yeah, £360, £370 in the UK, very expensive, but I think there's plenty here to like, even at that price point. Gigabyte's X570S Aorus Master offers up pretty much everything you'd want from an enthusiast class high-end motherboard for X570. The power delivery solution is pretty much market leading. It's about as good as you could reasonably expect from a board like this. The cooling implementation is absolutely superb. And then the implementation of some of the features, such as the quadruple M.2 slot, is really, really good to see. Now yes, the single 2.5 gigabit NIC is a little bit disappointing, especially at this price point in a world of 5 gigabit plus connections, but when you factor in the high-speed Wi-Fi 6E connectivity, the quadruple M.2 connectors, the smart overall design, and that exceptional SmartFan 6 interface, then there really is a lot to like here. So yeah, I can see a lot of enthusiast buyers getting very, very excited about this motherboard, even at the expensive £340 price point. There is a notable competitor from MSI, so the Meg Ace X570S, which is about £30 or £40 more. But yeah, I can see a lot of reasons for why Gigabyte holds its own versus that MSI motherboard and versus the other options at £340. And I wouldn't be surprised if this becomes one of the new go-to options like we saw from the original X570 Aorus Master. I really did enjoy working with this board, and I think it has a fantastic feature set and a well-built design. So yeah, let us know what you think in the comment section down below. Is X570 now finally a stellar choice for you without that annoying chipset fan? Is it a little bit late in the day? Are you going to wait for AM5? Have you been happy with B550? Or is this genuinely what you've been waiting for with the new 2021 feature set? Let us know in the comment section down below. I've been Luke Hill for Kikaroo. Thank you for watching this video review of the X570 motherboards from ASUS and Gigabyte. Hopefully you enjoyed it. Make sure you like, subscribe, support the channel however you can. Check out the written page on the Kikaroo website. Buy a cool t-shirt like this one from our merch store. Check us out on Patreon. Interact with us on Discord and Twitter and social media and the likes. And I'll see you next time.